development of abstract algebra by Évariste Galois in the 19th century was a significant achievement in the field of mathematics. Galois, a French mathematician, made contributions to the study of polynomial equations and group theory, which laid the foundation for modern algebra. Évariste Galois was born on October 25, 1811 in Berg-Larigny, France. He was a precocious student, excelling in mathematics and physics from an early age. However, despite his talents, he faced many setbacks in his academic pursuits. In 1828, at the age of 17, he failed his entrance exam for the prestigious École Normale Supérieure. This was a major disappointment for Galois, but he did not let it discourage him and continued to study mathematics on his own. Galois' early work focused on the study of polynomial equations, which are equations of the form of x to the n plus bx to the n minus 1, iteratively until plus cx plus d equals 0, where a, b, c, and d are constants and x is a variable. In the early 19th century, the study of polynomial equations was an active area of research, and many mathematicians were working to find a general method for solving these equations. Galois was particularly interested in equations that could be solved by radicals, which are expressions that involve only the four basic arithmetic operations: addition, subtraction, multiplication, and division, and the extraction of roots. In 1829, Galois submitted a paper to the Academy of Sciences in Paris in which he presented his ideas on the solvability of polynomial equations by radicals. The paper was rejected, and the reasons for its rejection are not entirely clear. Some historians believe that the paper was too advanced for the reviewers to understand, while others believe that it was rejected because of Galois' young age and lack of recognition. Regardless of the reasons, the rejection of his paper was a major setback for Galois, but he did not let it discourage him and continued to work on his ideas. Galois' next breakthrough came in the form of a new mathematical concept, which he called a group. A group is a set of elements with a binary operation, such as addition or multiplication, that satisfies certain properties. Galois' work on groups was a significant departure from the traditional algebra of his time, which focused on solving equations. Instead, he was interested in studying the symmetries and structures of equations themselves. In 1832, Galois published a paper on his work on groups, in which he introduced the concept of a Galois group, also known as a Galois group of a polynomial. A Galois group is a group that describes the symmetries of a polynomial equation, and it was an important step in the development of Galois theory. Galois' work on groups and Galois groups was a significant departure from the traditional algebra of his time, and it was not well received by the mathematical community. However, Galois was not discouraged by the lack of recognition for his work, and he continued to develop his ideas. In 1832, Galois published a paper on the theory of equations, which contained many of his most important results. The paper was published by the Academy of Sciences, and it was the only paper that Galois ever published. The paper was not well received at the time, and it received little attention from the mathematical community. However, it contained some of the most important ideas that Galois had developed, such as the concept of a Galois group and the Galois theory, which is a method for determining the solvability of polynomial equations by radicals. Despite the lack of recognition for his work during his lifetime, Galois' ideas were later recognized as being ahead of their time. His work on groups and Galois groups laid the foundation for the study of abstract algebra, which is the branch of mathematics that deals with the study of mathematical structures, such as groups, rings, and fields. Galois' work on polynomial equations and the solvability of equations by radicals also laid the foundation for the study of Galois theory, which is a branch of algebra that deals with the study of the symmetries of equations. Galois' contributions to mathematics were not fully recognized until after his death, which occurred at the young age of 20 in a duel. He died on May 31, 1832, and his death was a great loss for the mathematical community. However, his work was later recognized as being of great importance, and it continues to be studied and applied in mathematics and other fields today. In conclusion, Évariste Galois was a brilliant mathematician who made significant contributions to the field of abstract algebra despite facing many setbacks in his academic pursuits. His work on polynomial equations and group theory laid the foundation for modern algebra, and his ideas continue to be studied and applied in mathematics and other fields today. Galois' work was not fully recognized until after his death, but his ideas continue to inspire and influence mathematicians and scientists around the world. His work was a great contribution to the mathematical world, and his legacy continues to be celebrated today.